So let's see the part 2. Part 2 of motion of system. Motion of system of particles and rigid body. Rigid body. So let's see the next sum. That is 9th one. A bullet of mass 10 gram. Bullet mass is given, that is 10 gram. Horizontally, moving horizontally with a velocity of 400 meter per second. Strike a wooden block of mass. So it is moving with velocity 400. There is a block of wooden. Mass of this wooden block is 2 kg, which is suspended by light in inextensible string of length 5 meter, right? So it is hanged by 5 meter length of inextensible string. As a result, center of mass of the gravity of the block found to rise a vertical distance by 10 centimeters. After striking it, it is rise to the height of 10 centimeters. The speed of the bullet after it emerged out horizontally from the block. So you have to find out the bullet speed, final velocity of the bullet, right? When it is coming out from this block after entering. It is asked in 2016. So let's see. It is asked in 2016. Let's see the explanation. So as we know, it is observed that block rising through the height h, right? So this is your height h, that is 10 centimeters. So velocity is given by free fall, that is equal to 2gh. Now put the value 2. G value is 10 and height is 0.1. So it is coming out to be root of 2. That is equal to 1.414 meter per second. So this is your velocity v1. Right. So velocity of bullet after collision will be v. So using law of conservation of mass. So before a striking, conservation, and after coming out, law of conservation should be same. So this is called law of conservation of mass. Law of conservation of mass. So it is given by 0.01. So law of conservation of mass of momentum, of linear momentum. Linear momentum. Momentum is nothing but it is given by P equal to mass into velocity. So this is 10 gram given. So I will convert into kg. So it is 10 upon 1000. So it is coming out to be 0.01 kg, right? So written here 0.01 kg, and initial velocity we know that is 400. So put here 400 meter per second is equal to, next mass is 2 kg, right? So put here 2 kg into velocity we have find for this block is, that is 1.414. So right here 1.4 meter per second plus, right? Bullet mass again take. So it is 0.01, right? So it is 0.01. So we have to find this velocity v2, final velocity of the bullet. Now by this law you will get the velocity. So please solve it. So after removing this point you will get 100 here. So this will cancel this part. So it is 4 is equal to, unit will be kg meter per second is equal to this part. So it is 2.8 meter per second into kg plus. So it is 0.01 kg, right? It is 0.01 kg into V2. So your answer will be what? Take this on the left part. So it is 4 minus 2.8 kg meter per second, right? is equal to 0.01 kg into V2. Right. So subtract this one. So you will get 2.1 kg meter per second is equal to 0.1 kg into V2. Right. So let's see the next part, that is equal to 1.2 kg meter per second divided by 0.01 kg is equal to V2. You have to find it. So remove this point, you will get 10. Remove this point, you will get 100. So this point is cancelled with this one. So you will get 120 divided by 1. Kg and kc will be cancelled. So it is 120 meter per second. So velocity will be reduced to 120 meter per second, right? Initially, it is moving with 400 meter per second. Final velocity is coming out to be 120 meter per second. So this is the answer. Now see the next sum. 10th one. So two rotating body A and B of mass m and 2m with moment of inertia IA and IB, right? Two body are given A and B of mass m, that is 2m, with moment of inertia IA, this is IB, have equal kinetic energy. So their kinetic energy of A is equal to kinetic energy of B. LA and LB with their angular momentum. LA and LB use angular momenta. Angular momenta. So you have to find the relation between them. Now see the explanation. So rotating kinetic energy is given by, it is given by 1 upon 2 I omega square. I is your what? Moment of inertia. Moment of inertia. So it is also given by I equal to mr square. Omega is your angular velocity, right? So you can convert like angular momentum. So angular momentum is defined as L equal to I omega, momentum into angular velocity. So you can write here, I want here I square. So I will multiply and divide with I. So I into divided by I, this will be I by 2 into omega square. So numerator has become now I square omega square by 2I. This is your kinetic energy, right? So instead of I square omega square, you can write it down L square upon 2 of I. This is your kinetic energy. So you can directly observe that, take this here. So you will take L square as 2I into kinetic energy. So you can just observe that L square is directly proportional to moment of inertia. So angular momentum square is directly proportional to moment of inertia, right? As we know, EA is equal to EB, right? Energy of them is given, that is equal. So you can put here LA square upon 2IA is equal to LB square upon 2IB. So as we know, IB greater than IA. If IB is greater than IA, B will greater than LA. So this is the relation between them, right? They are directly connected now. That's why you can conclude this part. Now see the next sum, 11th one. 11th is talking about light rod of length L has two masses M1 and M2 attached at 2 in, right? This is the rod whose length is given L. Point mass M1 and M2, right? The moment of inertia of the system about axis perpendicular to the rod and passing through the center of the mass. So you have to find the moment of inertia about this perpendicular axis and this axis also, right? So let's see. So as we can find x1 value, that is given by M2L divided by M1 plus M2. Next is x2, that is given by M1L divided by M1 plus M2, right? So as we know, moment of inertia is defined as M1 x1 square plus M2 x2 square, right? Then it will be I is equal to M1. X1 value we know, so please square that one, then you will get M2 square L square divided by M1 plus M2 whole square plus M2 into M1 square L square divided by M1 plus M2 whole square. So it is coming out to be, this will be M1 M2 square L square, right? Numerator is same, right? So you can write M1 plus M2 whole square. This will become M2 M1 square L square. So take the common from these two quantities. So you will get M1 M2 L common, right? So remaining is M2 plus M1 divided by M1 plus M2 whole square. So this quantity will cancel one. So your final moment of inertia will become M1 M2 L upon M1 plus M2. So this is the final moment of inertia. Now see the next part, that is 12. Point masses M1 and M2 are placed at the opposite end. So diagram is given to it. So this is the rod, this is M1, this is M2. This is the axis of rotation, omega naught. This is the point P. This is the length of X. This is L minus X. So point masses M1 and M2 are placed at the opposite end of rigid of length L and negligible mass. Rod is to be set rotating about an axis perpendicular to it. Position of P on the road through which the axis should pass, so that required to angular velocity is given by. So let's see, first write the kinetic energy. So it will be A equal to 1 upon 2 M1 x1 square omega naught square, right? For the second one, it will be plus 1 upon 2 M2 L minus x square omega naught square, right? As we know, dk upon dx is equal to 0. So this kinetic energy has become now 0. So then you will get like, it will implies it will be 1 upon 2 M1 x1 square omega naught square will become equal to minus 1 upon 2 M2 L minus x square omega naught square, right? So 1 upon 2 get cancelled, omega naught square get cancelled. So you are getting as x1 square is equal to minus, right? Here M1 is also remaining. M1, this is M2 L minus x square. right? And so taking the square root both sides, then you will get this x will be reduced, removed, right? This is the square part. So it will become m1 x1 equal to m2 L minus m2 x. So you have to find x value. This is x1, this is also x1 then, this part. So it will be m1 x1 plus m2 x is equal to m2 L. So x will be m2 L divided by m1 plus m2. So this is the x value we are getting. Now see the question number 13. So 30 is asked in AIPMT. Let's see the next part, that is 14.1. 14 question is asked in me. So a small object of uniform density, whose density is given. This is your density. Roll up a curved surface with initial velocity v. So velocity is given small v. Right. It reaches up to maximum height. So maximum height will be is equal to 3v square upon 4g. With respect to the initial position, it is asked in NEET 2013. So let's see the explanation. So initial kinetic energy is equal to final kinetic energy. So it will be given by 1 upon 2 I omega square. So this is your rotational kinetic energy. Rotational kinetic energy plus 1 upon 2 mv square is equal to mg, put the velocity v 3v square upon 4 of g. So where all the particles are in the usual meaning. So after simplifying, you will get right. You will be coming out to be 1 upon 2 I omega square is equal to 1 upon 2 4 mv square. Right. So take this part on this on the other side. So it is 1 upon 2 I omega square. So this can be solved like this. So g and g will get cancelled, right? So write the remaining part then. It is 3 by 4 mv square remaining minus 1 upon 2 mv square. So it will become LCM is 4. So it is 3 mv square minus of 2 mv square. So it is coming out to be mv square upon 4 is equal to 1 upon 2 I omega square. Right. And as we know, v equal to r omega. So this is the relation between linear velocity, and this is your angular velocity. So omega is coming out to be v by r. Right. So put here instead of omega, then you will get 1 upon 2 I into v by r whole square is equal to mv square upon 4. So this is cancelled with by 2. Then I v square upon r square is mv square. So v square and v square will get cancelled. Or you can write up to this point only. Here 2 is remaining now. So answer will be I v square. I v square upon r square is equal to mv square upon 2. So this will be the relation, right? Now see the next sum. Next sum is 15. Let's see the question number 15. A rod PQ of mass M, length L is hinged at point P. So diagram is given like this. This is P, this is Q. This is your length L. A, a rod PQ of mass M. So this is your mass M rod. Length L is hinged at end point P. So this is the point P given to you. The rod is held horizontally by massless string tied to the point Q. So this is your string. There is no mass. Massless is this. So when the string is cut, the initial acceleration of the rod, you have to find it. So from here we are cutting it down. So you have to find the acceleration. It is asked in 2013. So let's see the explanation from the given figure. When the string is cut, rod will rotate about in and torque will be given by. So torque is nothing but it is force into perpendicular distance. So force is defined as mass into acceleration and R will be length upon 2. Here the weight mg of rod will act through center of mass gravity at the middle point. So it will be rotating at L by 2. So next torque will become moment of inertia into angular acceleration. Alpha is nothing but is your angular acceleration. This is I is moment of inertia. This is the symbol for torque. Right. So please balance these two, equation 1 and 2, then you will get mg L by 2 is equal to I into alpha. Right. So this is the relation you have got. Moment of inertia of rod about axis of rotation through L is. So moment of inertia about axis of rotation. About axis of rotation is equal to I equal to क्या होगा? It will be I will be m L square upon 3. For the rod, this is the moment of inertia given to it. So put this value here, instead of I. So then you can get L. So I will be nothing but it is m L square upon 3 into L. It is equal to mg L upon 2. Right. So L and L will get cancelled. M and M will get cancelled. So you have to find just alpha. So alpha will be 3g upon 2 by L. So this is the relation between angular acceleration in terms of linear acceleration and length. Now see the next topic, that is gravitation, right, of part 1. So its weightage is 4% in NEET. So let's see the first question. Escape velocity from the earth surface is given v. So v is your escape velocity given to you. The escape velocity from the surface of another planet having a radius r 4 times that of the earth. So there is another planet whose radius is 4 times of the radius of the earth and same mass density. Mass density is same. Mass density is same, right? So let's see. It is asked in NEET 221. So as we know, escape velocity is given as, from the escape velocity is given as, so V naught is equal to under root of 4 m naught into 2 upon 4 of r. Right. So density, mass density is same. So it is sigma me is equal to sigma m naught. Right. So me will be given as sigma me into V. So V is nothing. This is your volume. Right. So volume of a sphere is nothing but it is given by 4 by 3 pi r cube. So this is the volume of sphere. Then similarly you can find also m naught. So it is sigma m naught into 4 by 3 pi r cube. So for m naught I will put 4 times. So it is 4 times of r cube. So it is coming out to be sigma m naught 4 by 3 pi r cube into 4 cube is 64. Now divide V by V naught, right? So this is your V naught we have written here, right? So next is V. V value we know. So that is given by V value is GME. GME into 2 divided by R, right? Now put the value of ME and M naught. There your next slide is V by V naught is equal to under root of GME into 2 upon R we have taken divided by under root of GM naught into 2 upon 4 of R. Right. So this G and G will get cancelled, R and R will get cancelled. So put the value, those who have find it there, that is for M it is sigma ME, right? Into 4 by 3 pi R cube into 1 divided by under root of sigma M naught into 4 by 3 pi R cube into 64 upon 4. Right. So cancel these all quantities. Right. This will be 16. This is under root of 4 upon ME divided by M naught into 16. So this is cancelled by 4. Any 4 is remaining there. 4 by 3, this whole get cancelled now. So 14 is remaining. So it is under root of ME by M naught into coming out is 4. That is V by V naught. Right. So ME and M naught is same. So it will be also cancelled. So this part is also cancelled. So remaining is V by V naught is equal to 1 upon 4. So you have got V naught is equal to 4 times of V. So this is the answer given to you. Now see the question number. Second one. Second one, a particle of mass m is projected with velocity v. Right. So v is given as kve. k value less than 1 from the surface of Earth. Escape velocity, we have to find the maximum height of the Earth reached by the particle. Maximum height. So it is given by h max. So it is asked in NEET 2021. So let's see the second one. So as we applying the law of conservation of energy, so apply here law of conservation of energy. Conservation of energy. So write the formula first. So initial kinetic energy is 1 upon 2 mv square minus. This is your potential energy, right? It is given by minus of Gm small m divided by R is equal to total potential energy minus of Gm capital M upon R plus H, right? So find the relation between them now. So a small m will get cancelled, right? So your relation is V square upon 2. Take this on the right hand side, then it will become Gm upon R minus of G m upon R plus H. Right. So take the LCM now. Gm is common. So it is 1 upon R minus 1 upon R plus H. Right. So this is given by equal to V square upon 2. So LCM is Gm. LCM is R into R plus H. So here R plus H minus of R. So R and R get cancelled. So remaining is Gm H upon R into R plus of H is equal to V square upon 2. We are getting it. Now, see the next step. As we know, V is given as kV. So put in that formula. So then it will be kV square upon 2 is equal to Gm H upon R into R plus H. Right. And as we know, the escape velocity V is given by under root of 2 Gm upon R. So put here in this formula. So after squaring, VE square will become equal to 2 Gm upon R. So under root square will be removed. So this will become K square V square upon 2 is equal to Gm H upon R plus R into R plus H. So instead of V square, we will put now this quantity here. So it will be K square into 2 Gm upon 2 into R. Right. So this 2 and 2 will get cancelled is equal to Gm H upon R into R plus H. So this R and R get cancelled, Gm will also go. So it is K square is equal to H upon R plus H, we are getting it. Right. So we have to find here H value. Right. So cross multiply. So it will be R square K square into R plus K square into H is equal to H. So take this on the right part. So it will be K square R square equal to H equal to 1 minus of K square. So H is given by K square R upon 1 minus of K square. So this will be the relation between them. So please write it down now.